Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. My name is this video. I'm going to talk the chapter 4.2, which is tension and compression and torsion. Okay, which also in the chapter 4, deflection of and stiffness from Shigley Mechanical Engineering Design textbook. For engineering student in related the subject matter, you have the textbook with you so that you refer. uh, this video will give some additional information for you. I hope you can have additional information, additional knowledge. Of course, you should refer to your respective professors in this subject matter. You can scan this code for uh, for more uh, for more videos lah. Okay, from me. Okay, okay. Introduction to tension and compression in bars. Total extension formula. Extension or contraction of a uniform bar under pure tension or compression is calculated by this equation of F deflection equals to Fi over Ae. Key variables are applied force, length of the bar, cross section area, modulus of elasticity, material stiffness, and material stiffness. A steel rod stretches less than a wooden rod under the same load due to still higher modulus of elasticity. Okay. Limitation of formula, the equation doesn't apply if buckling risks are present and long slender bar. Okay, if this equation you might refer to the textbook. If buckling happen, okay, you cannot apply this equation. Okay, buckling that there is a one chapter on the buckling, meaning that it become compressed lah. Okay. So spring constant in axial loading, formula for spring constant for axially loaded bar. The spring constant K is calculated by this equation. Okay, you know about K, F equal to Kx. K, this equation come from this. Okay, concept of spring constant, the measure resistance to deformation in tension or compression, material stiffness and K, higher E values like steel and higher yield higher K, indicating stiffer materials. And example, spring length and resistance, shorter springs with larger K values resist compression more than longer ones. Okay. And angular deflection in torsion and circular bar, angular deflection formula, this angular deflection data in torsion is given by this equation. Okay. Key variables is T is twisting moment, I is the length, G is the shear modulus, J is the polar moment of inertia. Okay, for example, to torsion, the thicker range stuff has a higher J value. Resistance torsion is more effectively than a thinner one. Okay. So angular torsion meaning that if you have a circular bar or whatever bar, you want to twist it, it cannot be easily twisted because it is hard to twist. Okay. Imagine this circular bar. Then imagine like the straw that you want to drink, the straw, you can twist it because it made of plastic. Then can be twisted easily. Okay, but cylindrical bar cannot be twisted because it is hard to twist. Okay. So torsional spring rate and non-circular section. Okay. Torsional spring rate formula is given by this equation K equal to Gj per I for circular bar. Effects of diameter on deflection for solid round bars. Smaller diameters increase twist as shown by this equation. You can refer for the textbook. Okay. Non-circular cross section. Different formulas apply for rectangular or thin wall section. We have unique twist behavior and application close and open section like tubes have distinct torsion characteristics, like a critical in shaft and beams. Okay, so that's all for the video right now. Inshallah, we meet again in the next video lah. Thank you very much. Okay, we meet again inshallah.